Thanks everyone for showing up. With a title like this, Are We Really Cloud Native? It is probably obvious that I'm going to talk about cloud native computing. But as the spin doctors in the marketing departments of large vendors have starting to own this term, right, and apply it to their products and their offerings, I think it would be best to start off with some sort of a definition to basically figure out what is cloud native computing actually. Right? And so don't worry, I did my homework. So I scanned the entire internet, collected all the definitions, and then finally came up with this, common denominator, which is probably something like blah, 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 Kubernetes, right? And so in case you don't know what Kubernetes is the Greek god of spending money on cloud services. And so this quote is not mine. It's from Corey Quinn. He's a great guy. Follow him on Twitter. But well, this is kind of the direction where we're going right now. So somebody coined a term, and now it's a spin doctors trying to get a hold of it and applying it to products. So while we're on doing introductions, let me introduce myself. My name is Bert Ertman. I'm from the Netherlands. I work for a company called Luminous. I'm a fellow and VP of technology. And basically, I consider myself to be a Java/cloud postmodernist, as I think that we've entered the postmodernist age with Java, right? So we've seen classic Java in the 90s, and we've seen more modern versions of Java in the zeros and the tens, and now we're in the age of, mixing Java with all sorts of other stuff, and everything goes again, so it's postmodern Java. All right, with that out of the way, let me talk to you about cloud computing. So this is us, or me in this case, wondering, what is happening with this mythical beast called the cloud. And I can tell you a lot has been happening over the past couple of years. Because the cloud is obviously not something new, but in recent years we've seen a bunch of analyst papers showing up where companies like Gartner and also others have predicted and then confirmed the rise of cloud computing as opposed to more traditional non-cloud on-premise development styles. So basically they are saying that cloud services market is really growing fast and it's going at the expense of traditional offerings, which is Gartner speak for Java EE is dead and long live the cloud. And I'm a Java guy, so I put Java EE there, which has nothing to do with the whole Jakarta Java EE thing going on right now, but that's only making it worse. But still, if you replace Java EE with something like Spring or even .NET, it's probably still true, right? So this cloud thing is coming at the expense of something else. I think the only thing you can't replace it with is probably JavaScript, because as we know, JavaScript is not dead, it's the undead, so that will probably never go away. All right. So what is cloud computing to people in general? What is cloud computing to enterprises these days? And so I call in the help of a friend of mine, which is I consider him to be the typical Dutch entrepreneur, right? So if I ask the typical Dutch entrepreneur, what is cloud computing to you? Then he will probably tell me something like this. It's like computers on the internet, right? And we even designed our own bumper stickers for it. So there's people, wearing this with pride. There's no cloud. It's just somebody else's computer at the other end of the internet. And this is probably, true, say, 5 or more years ago. That was the state of cloud computing. It was just virtualization, but then taken elsewhere. But now, it isn't really doing the cloud any justice. So if you have to explain the cloud to enterprises right now, what I would do is something like this. I created some expert out of I screen scrapped a slide out of some Microsoft presentation where they put it up like this. They say, well, there's always something like on-premise development, right? So there's always be some on-premise component. Whether you call that edge computing or just plain old on-premise, that doesn't really matter. But then if you have to explain the cloud is basically comprised these days of 3 main components. Of course, there's the old stuff that we now know, like infrastructure as a service, which are like the primary building blocks for compute, networking, storage, stuff like that. And then we have PaaS, which is more of stuff with an API stuck onto it, so we can just wire it into our application development. Think of web servers, databases, message queuing systems, stuff like that. And then the third component, which is still a little bit newer, and which also breaks with the as-a-service tradition, is called serverless these days, which is kind of a funny name, but I think, in my opinion, is one of the most interesting things happening in the cloud right now. And so when I talk about it in this way, then the typical enterprise customer would say, well, what is this witchcraft, this serverless witchcraft, right? Can you elaborate a little bit more? So I would say, yeah, well, this serverless thing, you can see it as the evolution of compute, or you can see it as the evolution of virtualization, if you will. So if you think about it, not that long ago, when we were done developing a piece of software, we were basically installing it on a real physical machine, right? That was like 15 years ago. Some people still doing it, right? And then virtualization took over, so which basically meant we bought even bigger physical boxes, and then we started to emulate multiple virtual computers on top of that. And then at some point somebody decided, well, let's move these computers to the other end of the internet, and this is how cloud computing started, right? And then, well, that improved for a little while, and then we rediscovered something in the Linux kernel. We got containers, and to some people, containers are still the pinnacle of virtualization or the pinnacle of compute. But there's a little bit of news there because now serverless is taking over, which basically means we take a smaller piece of software that we want to run, and then we glue it to some sort of compute at the moment you want to run it, right? And this might seem funny at first. But there's one thing that has been holding us back for many years now. And this is that maybe after 50 or 60 years of doing compute and developing software, we are still holding on to the concept of a computer. So whenever we create a piece of software, then in order to run it, we need a computer. And this is basically like a strange thing, because computers, in some ways, compare to pets. I mean, look at it. It's like adorable, right? So if you get a new computer or a new pet, then you are, really fond of it. You give it a name, and you take really good care of it. But then, at some point, it becomes a little sluggish, right? Oops. It becomes a little sluggish. And you also have to walk the dog when it's raining outside, right? And the maintenance becomes a little bit of a drag. And it gets even worse if your pet goes belly up, and the same thing can be said for computers, right? Then you get really upset. So instead of thinking about computers as pets, we should learn to think about them as cattle. So in this example, I have a group of cows, and with a group of animals, I am not so much interested in the individual animal. I am interested in what the group of animals produce, right? And so in this case with cows, it could be milk, right? So in case of a bunch of computers, what they produce is compute. And so serverless to me is like it's like a saw, like an instrument to saw off the last letter of the word computer. And this will free me from thinking in terms of deploying my software on an actual computer. And if you can get rid of this idea, a whole new world will open up, as I will explain in a minute. And so yeah, my little Dutch entrepreneur friend is like a little bit confused here. But what I'm actually talking about is reimagining computing without computers. And yeah, spoiler alert, also in the serverless world there will still be computers, right? There will still be servers that will eventually run your software, but I no longer care about them. And the thing is, it all started off with running like a function on top of some sort of compute. But I think the direction in which this is going is far more interesting. Because if you dare to take this one step further beyond compute, I would say, what if we can reimagine our middleware or even higher level services as completely managed services which we can consume as an API? This will free up an enormous amount of time and investment that we usually have in installing and running these kind of things on hardware, on infrastructure, right? So if we no longer have to take care of installing, running, patching, and managing our database, our web servers, our storage solutions, whatever, that will free up an enormous amount of time and effort that we can put into developing software. So in a way, you can compare this whole trend of serverless with what happened to the steam machine back in the days when electricity was introduced, right? So if you think about serverless in this way, then in a way, we can now start to take both compute, networking, storage, but also middleware services and even higher level services out of the wall socket only when we need them. So it comes as like a utility, right? And you also only pay for them when you actually use it, which is maybe the economic model which was evangelized along with the whole idea of cloud computing, but never became a reality, because every time we fired up a virtual machine in the cloud, we left it on 24/7, so we paid for it 24/7. And now, if you can only use compute or database or networking or whatever just on demand, just for a little while, you only pay for it for a little while, right? This is a really interesting economic model. So to me, this whole serverless thing is a very important aspect of the direction where the cloud is actually going right now. And so depicting the cloud as just a virtual computer at the other end of the internet certainly does not do it justice and is not really keeping up with the actual state of affairs. So serverless is really important, and we're not there yet. I think yesterday there was an excellent presentation on why serverless is improvement in one direction, but then going back in some of the other directions. And I would certainly not claim that it is perfect yet, but I think the direction where we're going is really, really interesting. And it's still a very young technology, right? And so I'm really eager to see where this will be going in the next couple of years. So let's leave cloud for a little bit here. Let's talk about what is happening in the rest of the world. And don't worry, we only got, say, 35 minutes, so I will not turn this into some political rant, right? What I'm talking about is, apart from technology, right, where are we going? What's the direction where we are going? And this direction has been laid out for us a bunch of years ago when this guy, Mark Andreessen, wrote the famous paper about how software is eating the world. And I think this is still true. And maybe it's even going faster right now. And there's lots of young companies to prove that they have overhauled existing business models. And there's lots of old companies no longer around to prove that this is actually happening, right? And so in order to deal with this new world order that came upon us, right, with traditional business that needed to evolve and adopt faster, right, we needed ways to think about how we can move faster without breaking all the stuff that we have around. Because if you look at most enterprises, they are not like, Silicon Valley unicorns, right, which are only interested about, doing new stuff and more new stuff and even newer stuff, right? Because they have their existing business to take into account. And they have lots of stuff which is already there and which they need to take care of. And you cannot just move fast without breaking stuff, right? So in the meantime, in the past 5 to 10 years or so, we came up with some of the answers in order to try and move fast and not break things. And these answers comprise things like this. So in order to adapt more easily to change, right, we kind of invented the whole idea of microservices, and we tried to adopt that. And then in order to not break things, we came up with processes like CI/CD, and we introduced containers to make things portable across environments. And then we sprinkled a bit of process on top of that. So we tried to transform not only our development teams, but also our business into an agile organization, right? So we only built the stuff that we actually need, and we built it in a timely fashion. And then we sprinkled a bit of DevOps on top of that to be able to integrate the whole thoughts and ideas of CI/CD and containers into the solution of deploying things into production faster. And so while doing this, while applying all of these things, this resulted eventually in, something like this, right? And this is good, right? This is good. Because this is a screenshot from a Netflix architectural document, right? So if this is what Netflix has, then it must be good, because they're the poster child for microservices. So if this is their architectural landscape, and if our architectural landscape starts to look like that, then it must be good, right? So who's happy with this as their architectural landscape? Nobody? Oh, okay, one. Yeah, sure. Because this screams microservices all over, right? So this is good. But somewhere along the way, we probably ran into some trouble, right? Because transforming it is not only applying new and more technology into the mix, but it also involves a very heavy component, literally, in terms of, transforming the organization along the way. And so one of the first things that we actually learned while starting to do this is we learned that 80 to 90% of real enterprise budgets, right, are being spent on maintaining existing systems, right? So that's just maintaining the status quo. And the trouble with this is that you only have, say, 10, 15% left for doing new things. And within that 10, 15% margin, right, that's also where your amount of money or time is for experimentation. So if you want to start experimenting with new stuff, with new technology, with new process, with whatever new, right? Then you got to find the time and the money in order to do it. And this proved to be really, really hard. And then, even if we took our existing workloads, let's say we have our Java EE app, right, our monolith, and we bring it to the cloud in a lift and shift fashion. And so we took it from maybe real hardware or virtualized hardware on-premise, and then we moved it towards the cloud, and we ran it on top of some virtual machine at the other end of the internet. Is that really helping us out in our journey of getting more money and time available, right? Saving money on the infrastructure so we can spend it on other stuff? No, right? It turned out to be a false promise of the cloud that if you just move your applications into the cloud, you would start saving money, right? In most cases, that's just not the case. If you just look at the total cost of ownership, you probably spend more money running your existing apps in the cloud than you do when you run it on-premise. So then some companies started to say, well, it's probably the framework and the app server which are evil, right? And then some books showed up doing cloud-native Java with Spring Boot, for example, right? So what did they do? Well, they started out small. They started rewriting their logic, and then they checked all the boxes in the Spring Boot configuration, and then they ended up with what I would like to call like a fat jar, an even fatter jar, and eventually with an inverted app server. Because to me, I don't see the difference between running an enterprise Java application in an application server or running it in Spring Boot server with all of the boxes checked. Yeah, you have you're all Netflix compliant, but it doesn't necessarily mean that you get any advantage of running this stuff in the cloud, right? To me, it's just the application server upside down. But then some might say, well, you forgot the magic ingredient because you forgot to put Docker in, right? So put it in a Docker container and then probably you're better off, right? Okay, now I made it a little bit more portable, right? So I could probably run it on my laptop on some test environment and then move it into the cloud. But still, I'm not really getting the benefits of what the cloud has to offer. And so this is when the ideas of microservices were introduced, right? And so we said, okay, now we have to break up this monolith, and then we create lots of smaller services, right? And still we put them in Docker containers, and then we put them on virtual machines in the cloud. And now, while this may be a good attempt at doing microservices, right, we're probably even wasting more resources because we now need even more virtual machines in the cloud. And we got to find out a way of managing a bunch of containers at scale, right? So we introduce more problems, but we try to solve other problems. So, you can ask, well, are you saying that microservices are a bad idea? No, that's not exactly what I'm trying to convey here, because to me, microservices are like a modularity tool. And modularity is always a good thing, because it's breaking up bigger structures in smaller things, so they're easily solvable, and it's hiding the details of implementation and then connecting stuff together using like some sort of a contract. So basically, this is about the first thing that you learn when you start to do software design: cohesion over coupling. And there's a bunch of ways how you can introduce modularity. So some do it on the code level. So if you have like a big code base, like a large code base, right, then you can start to introduce modularity on the language level. So with things like the Java module system, or with OSGI if you like, you can start to break up a bigger code base into smaller modules and then glue them together. So when the pace of innovation or the pace of change goes up, that you are more confident when you start modifying things over here, that things over there will not break down, right? So modularity is always a good tool. And to me, microservices is just another level of doing modularity. So if you break up the monolith, if you break up the large code base into smaller parts, right, then you need a tool at that level to do modularity. And so microservices, to me, in essence, are a modularity tool. But then, if you start to break up the monolith into smaller pieces, and you put a network in between, you suddenly realize that there's a very high price to pay. Because decompositioning it into smaller services does not come for free, right? And if you start moving those kind of things to the cloud, especially to public cloud providers, you're probably not the only one on the network. So what happens with dependencies between services, right? And what happens when the network is starting to play tricks on you, right? So the fallacies of distributed computing, paper from 1995 probably, has never been more true than today, right? So designing distributed solutions, designing decomposed solutions is very hard because there's a whole bunch of things. So we're trying to solve one thing, we get a whole bunch of new problems, right? Or challenges, if you will, in return. And so the answer to that is probably Kubernetes, right? Because that's what everyone is saying. But is that true? Because let me add Kubernetes into the mix, right? So there we go. Just another layer of abstraction. And yes, maybe we find some answers to the problems that I listed on the previous slides, right? And maybe we now have some better resource utilization, so we can do off with less virtual computers, right? So that's a little bit of optimization there. But then running Kubernetes as a platform, that is a complicated beast. And I've seen lots of companies struggle with it. Because everywhere you go these days, even a conference like this, right? There's at least a bunch of sessions on Kubernetes, and everybody is telling you, go do this, this is the future of everything, go do Kubernetes. And don't get me wrong, I'm not against Kubernetes, right? I think that the problems that it solves pretty well. But then I'm trying to say here that Kubernetes is not for everyone to run and manage in production. Because I've seen lots of teams struggle with getting their setup right and then running that into production, right? That is really, really hard, and installing a lot and lots of progress because it's such a complex beast. Another huge problem area is DevOps, right? You say, well, DevOps is not new. How can this be a problem area? Well, the thing with DevOps is that there's parallels to draw between DevOps and Agile. If you think back in time, when we started doing Agile, the whole idea of Agile was really well received, right? I think we didn't take us long to understand what it was about. It didn't take us long to understand what the benefits were, and then we started introducing it. But in order to reach a certain amount of maturity with things like Agile adoption, it took us quite a few years. And this is not because we were stupid as developers. This is because we had this heavyweight thing dragging, behind our feet, in which we had to transform the organization as well. Because Agile is only getting some maturity as soon as you also have some buy-in from business, right? And if you think, well, product owners, who needs them, right? We can ask the architect, right? That's probably a very stupid thing to do, and that's what we learned over the years, right? And so DevOps is basically the same thing. It is not about learning a few new tools, right? Or mixing and matching like some software engineers with some, out-of-work DBAs, right? That's probably not the way to implement DevOps. And so the problem with DevOps is dinosaurs. I'm not talking about the DBAs here, by the way. The problems with DevOps is dinosaurs. And for short, it's called Dino, and Dino is DevOps in name only, right? And the thing with that is, dinosaurs are extinct. And if you don't want your organization to go extinct, right, then you have to pay attention to how you implement DevOps. Because let's think about how traditional organizations run their infrastructure and run their operations. In most traditional operations, they try and standardize everything. And for good reasons, right? So they try and standardize a hypervisor, all infrastructure components, even programming languages, everything, right? This is for good reasons, because it is, on one hand, to manage complexity, right? So we standardize on this, so we don't have to do that, right? It's also to apply some sort of a standard way of working, because in very heterogeneous landscapes, it's pretty nice if there's like a select set of choices instead of, pick anything you like. And also in some ways, standardization is some sort of a weird, maybe productivity tool, because if you depict it like this, and usually when somebody shows you a picture of an iceberg in the middle of a presentation, it's bad news, right? But in this case, it's not that bad. Because what we actually do by standardization is we create this waterline, and everything under the waterline is standardized. So our infrastructure, programming language, everything. And then our development teams just concentrate on getting a deliverable out the door, which is usually something portable like a container or maybe an ER file or a fat jar. And the only thing we have to do is land that thing on top of standardized infrastructure. So in that way, it is some sort of a productivity tool, because everything under the waterline is already spec'd out and you know what to expect. And then you just create the software, and then you put software and infrastructure together, and this is how it works in most organizations. And to some degrees, this solves problems. To some other degrees, is probably not the way that you want if you want to move fast and not break things. And if you try and translate this to the current time and space that we live in, and you try and reap the benefits of cloud computing, then this iceberg will look a little bit different. It will probably look a bit like this, right? And now this whole separation of where the application is and where the infrastructure is, it's gone, right? But because what we're trying to create here is we are mixing and matching functional components, infrastructural components, even more infrastructural components to run our infrastructural components, and everything in between, we're mixing and matching that into an existing solution. If you think about whether you're doing microservices or not, if you think about what is an application, right? If you think about this for a second, and you try and come up with an answer in, let's say, 10 years ago, let's say the 2009 answer to this, right? That would probably be like, well, an application is like a bunch of code that I build and test together, then I toss it over the wall to the ops team, and I hope they can get it to run on like a bunch of servers that they have provisioned, and then I hope that there's like users trying to use this application, so we're not wasting too much dollars on our investment in infrastructure and everything else. And that was a pretty obvious way to do it. But now, the 2019 answer would probably be something like this. Right? An application is probably like a mix of a bunch of managed services in the public cloud connected and customized with our own highly differentiated business logic, and then we glue everything together, which then runs and bills only when needed. So when nobody runs it, we pay nothing, right? And if there's a lot of users, then we pay some more money, but we're probably fine with that because that seems to be like a nice economic skill, right? So CloudNative in this is some sort of a DevOps journey to me. If you want to be cloud native, it's not about picking a framework or a tool. It is a transformational journey in getting DevOps right. And basically, I'm not sure I'm allowed to say it, but what it actually is about is like hooking stuff together. Let's call it like that. Yeah? It's hooking stuff together. Because if you want to reap the benefits of the cloud, you really have to know all the services that your cloud provider has to offer. Because if you want to package some sort of a software component to a Docker container, and you take that Docker container to your cloud provider, say AWS, right? And then there's at least 4 or 5 ways to run Docker containers on AWS. And figuring out which way actually suits that particular application, right? Or that particular component, that is what Cloud Native is actually about. It's about keeping up with all of the advancements that your cloud provider is actually making, and then try to apply that to your software components. And gluing the software and the infrastructure together is something which is not, this is not like an end state, right? This is like a continuous journey. So you keep on improving this with new services seeing the light of day and new components seeing the light of day. And because we're microservices, right, these services could also be short-lived. So if the service changes or gets replaced by another service, then maybe the new way of deploying it is different from the old way of deploying it because there's new services that became available. And so it's not thinking about servers and managing servers at scale. It is thinking about managing a mixture of both software and infrastructure at scale. So it's about services and consuming everything as APIs and gluing that together as a deployment. And so, like I said, it's a DevOps journey because it's about modernizing your infrastructure and the process of actually moving faster and not breaking things, right? And so the organizational culture plays a large role in it. I will get back to that later on in the presentation. Because if you think about it, this is the picture that I showed you earlier, right? There's these 3 components that we can pick and choose from in cloud computing. And I want you to think of these as, collection of boxes full of Lego components. I'm a big sucker for Lego. Any other people in the cloud that really like Legos? Yeah? Yeah, okay. Yeah, guilty pleasures, right? Okay, so think of them as Lego, right? So we have, boxes that comprise of Lego parts which have like the primary building blocks for infrastructure as a service. Then we have the stuff for PaaS, and we have serverless stuff. And so my advice would be that if you start assembling your logic and your infrastructure together, that you start from the ladder. So in this case, you start from the serverless box. And if the serverless box is providing you any good options to run that logic on, then I would definitely go for that. However, it highly depends on your workload and whether you're meeting your non-functional requirements and even whether you're meeting your economical requirements. Because even when you do serverless and it's true pay-as-you-go, it can still be more expensive than if you solve it in a more traditional way. Highly depends on the workload, right? So start by assembling your application from the serverless box. And if something is not in there, or if it's not fitting, then you go to the pass box and you start applying some of the pass pieces into the solution. And if that still isn't the complete answer to your solution, then you mix in some of the old infrastructure as a service stuff. So maybe you still mix in some virtual instances, right? And you mix in some of the storage types of the old cloud world. And eventually, you come up with a solution like this. Once again, this is an AWS example, just for illustration purposes. But if you look at this example, I can highlight a few pieces out of it. You see that this is a mixture of, say, serverless technologies like Lambda and S3 storage and API gateway and stuff like that. And I mix in some PaaS stuff. Maybe there's some Beanstalk for some old servers in there. And then I also have some infrastructure as a service because I need to run some older pieces on some virtual computers. And then tying everything together is eventually my application or part of my application landscape, which I then deploy to my cloud provider. And getting to know the services of what your cloud provider has to offer and really tuning your software to the underlying infrastructure, that is what CloudNative is basically all about. So technologies or frameworks are not going to make you cloud native. Right? So somebody says, well, this is the cloud native framework, right? That's probably a big lie, right? It is the way you use them and you embed it into your process of delivering value to your business. Because then we are finally entering the stage where we get the true value of the cloud. Because if cloud is no longer just virtual computers, then what is it about? Well, to me, it is about potential for economic disruption, right? So instead of doing this huge upfront investment in buying hardware and having dedicated personnel around to basically operate your data center and run all your infrastructure and manage all the infrastructure, I can now just use it on the go, right? And I can just integrate it as an API. So I can start experiments. So even if I'm in a classic enterprise situation where there's a tiny amount of money to start experimentation with new stuff, right? This is a really fitting model because I can take some cool higher level services from cloud providers, start to experiment with this, and if it's not going into the direction that I desire, I can just cut it off, right? Switch everything off, and I'm no longer paying for it. And my investment has been tiny. Right? So I still maybe save some money for other experiments, right? And if it is going the direction that I want it to go, right, then I can try to put it into a new development project, right? And this is how you can start to adopt new technologies out of experiments, right? And this is where the economic disruption lies. It doesn't necessarily mean that it's going to be cheaper. So if your main motivation for going to the cloud is going to be cost savings, well, it highly depends on what you choose. So cost optimization is also a responsibility of the DevOps team. Right? So your team of engineers, right, has to keep an eye on the bill. And so in some organizations, this is going to be really weird. Because if you say, well, my developers or my DevOps guys or girls, they have to look at the bill in order to figure out if this or that is going to be like a better way of running things, then there will probably be departments that will say, no. You can't look at our cloud bill, right? That's classified information, right? But so this is just a signal of how we need to transform our organizations, right? So we need this transparency in order to make the optimal choices here. And so cloud definitely has an edge for experimentation, like I already mentioned a couple times. And then I think the key thing here is that determining where your true strategic value lies as an enterprise. Is it in operating your own Kubernetes cluster and trying to play cloud provider by yourselves, right? Or is it in far more of a functional perspective, where you have a competitive edge, right, because you can deliver a great service instead of playing cloud provider, right? Which is, well, for some companies it is about playing cloud provider, right? And for some companies their interests are elsewhere. And in that case, I would highly recommend try to reap the benefits of what the cloud providers have to offer in that space. And I would like to add that friends probably don't let friends build their own Kubernetes platform, right? Because if you think about it, if you want to get the best from the cloud, sure, I have nothing against Kubernetes. And if you're fine with that, if you think it will yield you some strategic value of doing it, fine, go ahead. But we are probably not all networking experts and experts on all the stuff that you will run into when you start to do distribution at this scale, right? So if I have the choice of doing this myself, or I can leverage some higher level managed service offered by my cloud provider, and it's good, right? Then I would definitely choose that one over the other, okay? So another interesting question that we get asked a lot is, in this new world of cloud computing, is Java still a natural fit? Right? Because, yeah, well, if you look at the examples which you see online, it's all JavaScript and Python all over the place, right? So is it time to, get rid of Java and start learning another language? Well, this morning, I think Brian Getz said in his talk, well, if I get $1 for every time that Java was declared dead, I would be a very rich man. And I think that is very true. So in this case, I would say, well, I think there's advancements in the language, in the ecosystem, which will make Java a good fit for cloud computing if it's not already there, right? And there's some really cool things like GraalVM, for example, right? And compiling to native code. And so some of the cloud providers allow you to bring your own runtimes. So if you want to do, say, Lambda on AWS, you can bring the Graal runtime along with that. And that will probably solve some of the cold start problems which you can face if you just do regular Java on Lambda instead, right? So I think Java will find its way in the cloud. I think a better question would be, are Java programmers a good fit in this cloud age, right? And so the answer to that is probably, well, if Java is your only skill right now, then you're in for a hard time. Because with DevOps, there comes a whole new set of responsibilities and problem areas that you need to be knowledgeable about. And so I found this great roadmap online. I'll show you the link to it later on in the presentation. But what does it take to go from being a programmer to being a cloud engineer, right? And apart from all the details, right, it starts with picking a language and learning a language, but then you go into understanding operating system concepts. You learn about using the terminal. You learn about managing servers, about scripting, low-level networking stuff. What have we? Middleware services. Infrastructure as code, there's a lot in here, right? And all of these things, you need to master them in your DevOps teams in order to create software components and run them in this brave new world of cloud nativeness, right? And on top of that, this diagram ends with, oh, by the way, you have to pick a cloud provider, right? So let's look at one of those cloud providers. This is AWS's release pace over the last couple of years. So in 2013, they released about 1 new feature a day, right? Last year, they broke the 2,000 new features a year barrier, which comes down to 6-7 features a day. So how do we keep up, right, with all of this new stuff being poured on top of us? And I mean, we knew this when we signed up for this profession, right? So when you want to do IT, you're entering a profession of lifelong learning. But to be honest, for the past 15 years, we have been way too comfortable with that, right? But now, there's so many things changing at a very fast pace, and you have to master all of them. Not by yourself, but in your teams at least, right? And so in order to do this, this requires another piece of organizational change. The organization has to be aware of this, right? And there needs to be room in your daily work routine to master all of this. And so organizational culture is very important. So I ran across some really good cloud-native culture killers, right? And most of them are about that the business doesn't really trust IT, right? So whatever we think of, right, as developers or as ops, right, it will probably never work because there will never be any true biz, dev, sec, ops, whatever the latest abbreviation is these days, right? And because there has to be buy-in across the organization to get this to work. The other thing which is really dangerous is, the cost-cutting mindset. And once again, if you're like a heavily VC-funded unicorn, then you're probably not worried about this because you only think about new opportunities, right? But if you're like a traditional enterprise, then there's a whole bunch of cost centers there. And so cost centers are a place that we're not really fond of and that we try to optimize all the time. And so we do reorganizational stuff and we try to optimize the cost centers out of the way. And so if you think that IT is the way to do cost optimizations, then you'll probably never reap the benefits of going down this cloud-native route because the price you have to pay to get there is way too high. There's way too much upfront investment that you need to do in order to finally reap the benefits, right? And if you just think that the cloud will save you money, I think there's now more than enough war stories around of companies that had this exact same thought that will immediately prove you wrong. By going to the cloud, we now pay much more dollars for running our infrastructure, right? Those kind of stories are around. And so this is a very dangerous mindset. Not only because you will probably never get DevOps implemented in organizations like this, but also because culture seems to be the #1 killers for people leaving you, right? So if you want your good people to leave, then make sure you have a really shitty culture, right? Then they will all go. So it's not about the pay, it's not about the managers, right? It's about culture. So if people don't like the culture, then they leave, right? So culture is something that you should take into account. So let's try and turn this around then. So what are some, really good cultural aspects for trying and achieve this, this DevOps journey, this cloud-native journey? And I think it starts with the whole thing that we call digital transformation these days, which is another horrible buzzword, so please forgive me. But I think for most of the enterprises, it is about time that they realize that they are no longer a bank, right, or a financial institution, but they should realize that they're an IT company, which happens to be in the financial services space, right? And this is a really important mindset. And we can tell from many stories out there that the companies that started to adopt this mindset made huge leaps forward, right? Because then IT will not be a cost center anymore, and they will need to adopt their process of delivering software. And this has a far more a natural match with things like adopting Agile and adopting DevOps. And so if you think back in this, about this parallel about Agile and DevOps, I think that it took us maybe 5 to 10 years to get Agile right, okay? And so if we apply that metric to DevOps, if it will take us 5 to 10 years to get DevOps right, with all of the power of the cloud out there for your competitors to reap, right, then you might not have 5 to 10 years, right, because you will probably be out of business in that time, right? And this is a very, disturbing thought, right? So, the cloud should actually be seen as a potential for economic disruption over a way to save costs. And it's also a perfect way to start experiments, right? That does not necessarily mean that if you start experiments in the cloud, that you have eventually got to run them in production in the cloud as well, right? If you like what you see, you can also bring it back to on-premise and still run it on-premise, but the cloud will just give you like easier access to all sorts of resources and higher level services, which you can start to leverage to really do some cheap experimentation, right? Then eventually that will lead to, hopefully, faster time to market, and that was basically what it was all about when we talked about, software is eating the world, right? And then the final and maybe the key ingredient to it all is that you have to take into that you have to take into account that your engineers are broadly skilled, right? If you can just do Java programming, right, then that won't cut it anymore. And so in some of the companies that or some of the customers that I have been working with, they say, well, we do the 20% time thing, where we just give you a day a week, right, to start experimenting with services that our cloud provider of choice have to offer, right? So it's not a day to build games or something, or to play games, right? But you do it's still work, but you start to experiment and start to explore the world that your cloud provider has to offer, and you start to explore the tools and the frameworks which are out there, so that you can leverage these services and these skills. And sometimes they also do certification because, well, for some reason we like to get certified, or maybe we don't like to get certified, but our employers like you to get certified, right? And then you get some time for that as well. But having this time to experiment, this time to learn, right? Also to learn from each other, that is a really important aspect in making this transition. And with that, I'd like to thank you for your attention.